Hello everyone, this is Dr. Lauren Gresham over at Nutima Integrative Medicine. So today I wanted to talk to you about some of the mechanisms of vitamin B12. The pathway I'm going to go over is not the only pathway where we use vitamin B12, but it is one of the major, big, huge building block pathways. My picture is really tiny. If you ever want to come in person and see it, I'll show it to you in person. So bear with me if it's a little on the small side. Basically, what we do is we take, so a methyl group is just a carbon with 3 hydrogens attached to it, and then it gets attached to other molecules. We use methyl groups, you'll see in a second, to do a lot of different things. We actually can use them to turn genes on and off. We use them to synthesize a lot of different things in the body, like to make different molecules. And so you'll see I've got a list down here of some of the really important things that we do with that. So folic acid gets methylated, and then folic acid gets methylated and gives its methyl group. It's kind of like a relay race. They give it to vitamin B12. And vitamin B12 then gives this methyl group to a compound called homocysteine. Homocysteine then once it gets that methyl group becomes a thing called methionine, and methionine gets a methyl group and then becomes this molecule S-adenosyl methionine, which is a really important molecule for, that's where we actually, like, that is the molecule that mostly goes and regenerates a bunch of other things and actually goes and synthesizes things. So the whole take-home message of what I'm just trying to describe here is that this is a vitamin B12 and a folic acid dependent process. So why do you care? Why should we care about S-adenosyl methionine or these methyl donors that are dependent on B12? Well, specifically because we make really, really important things. We make our epinephrine using S-adenosyl methionine. I'm just going to call it SAMe from now on, in order to synthesize our adrenaline, which is like, you know, we think of adrenaline maybe in like a negative way, but actually like it's a huge important part of balancing our nervous system, because we need that stimulated nervous system as well as the relaxed nervous system. We use it to make creatine, which is an important molecule for muscle function. We use it to make basically all of our nucleotides, which is the DNA backbone of all of our cells. We also use it to make phosphatidylcholine, which is a really important molecule for lubricating our brain, keeping our brains really healthy and happy. And we also use it to make melatonin, which is the hormone that we use when we sleep, that helps give our brain signal for sleeping. It's also a really important antioxidant for the brain. So those are the important pathways that are dependent ultimately on folic acid and B12 in order to actually make these molecules that give these methyl groups. Also important to note is that when we don't make methionine, we build up a thing called homocysteine. So homocysteine is associated with basically most notably cardiovascular disease. At a cellular level, it does a bunch of the damage that we see when the actual arteries get damaged. The muscles get hypertrophied, so they get overlarge, making the space more narrow. It increases the likelihood that platelets, which is the blood clotting molecule, gets accumulated. And so that's very much associated with increased risk of cardiovascular disease as well as blood clots. So not good. We don't want to build up homocysteine. Unfortunately, vitamin B12 can be a little bit difficult to get in our diet because only bacteria make it. And sometimes people think that just vegetarians and vegans are people that can get deficient, but actually that's not true. So it is really important. It's a complicated digestion of B12. I'm not going to go through it all, but there's a lot of ways. If you have any GI issues, they can be difficult to get your B12, or any restrictive diets, or just our soil supply. It is definitely one of our more common vitamin deficiencies. So that's my plug for vitamin shots. That's why getting them intramuscularly can be a really great way to boost these pathways. Yep. So that's my biochemistry lesson. Please feel free to comment, ask questions, come and talk to me here at the clinic. I'm always happy to talk about biochemistry. Bye.